I'm back!
Lemontron Endgame revision. Endgame lemon extruder. Oops, all PTFE. Some kind of tail. 8 times the cooling power. Wraparound parkour fan. In-game repeatability. One-handed bed. And so much more.
This Lemontron Endgame update changes everything. Literally, I scrutinized every single measurement and feature to max out cooling, repeatability, stiffness, and ease of assembly. If you're new to the channel, well, this is your introduction to the Lemontron, a positron-style 3D printer that folds down to fit in a filament box, and yet it can print almost as big as the printer itself. Last year's open source announcement video put the Lemontron Rev A in front of the world with 115,000 views. I was expecting a flood of armchair experts, but I received nothing but positivity and a friendly Discord community. If you've been on the fence, well, this latest update could be the one that convinces you to build your own. In this massive 1-year recap, I'll share what's changed throughout revisions B, C, and D, and the release of E, with hundreds of changes, large and small. This channel is sponsored by PCB Way. More on them later.
Rev B.
Rev A was no slouch, but some of the earliest changes were based on your feedback. Countersinks seem great at first glance, but look closer like Aiden Dunlap did. Horizontal countersinks like these run the risk of splitting the layer lines, and vertical ones also stress out the seams they touch. So I started removing countersinks, starting with the Z-axis mount. It wasn't much, but it marked the beginning of the campaign for DFM. Another quick win was changing the 90-degree teardrop angle to a more aesthetic 120 degrees, and now the holes look even better. And finally, I also fixed the collision issue with the Meanwell LOP PSU. This all resulted in the swift release of Rev B just a few days after the video dropped.
See?
Next up, I noticed my tool end's top cavity was bowed in. So I beefed up those mounting points, and now you can tighten it down to the carriage without being so delicate. But I had not discovered counter bores, so we're still stuck on counter sinks. That was almost it, just a tool end update. But as you might know, I have already shaved down the screw bomb to just 13 different ones, but I still saw room for improvement.
Welcome to the Lemontron Battle Royale! 13 screws will compete head-to-head to see who's worthy of being in Rev E!
This single M2.5 screw to clamp the wires in was cramping my style, so a quick swap and we're down to just 12 types of screws now.
Elimination.
Rev C was a solid update, and the screw thing made me ask myself if I had stopped short of the maximum screw savings. There were 6 more screws that we don't need. If Rev B and C were the warm-up, Rev D was the glow-up. I took my time on this one. Previously, there was a long-standing collision where the tool head could knock into the bottom of the bed holder bracket. I was gonna fix it, but it was outed first by one of the Discord members. Not only did I fix the issue, I swapped out the countersink for a new screw. This was the first new screw, the 25mm wafer head. This little guy would go on to become history's most important screw. I can't add a screw without killing another one to keep the cosmic balance, so I looked for a blood sacrifice. Turns out, if I move the heatset inserts to the top side of the chassis, not only did this assembly get easier, but I could also eliminate
2 more screws!
Oh, and remember those gloop blobs. Gone. It starts with using the correct diameter hole, but also add to that a goop zone, and learning the absolute most basic brass insert techniques. And you get a result that can only be described as machine quality perfection. The secret is just backing off before it's all the way in and pressing it in the final millimeter with some flat, thick metal. Thanks to Nomad for the tip. It impresses me every single time, and now I finally understand why people find this so satisfying. Just look at the results. I made that with my hands. Screw review time! At this point, all 11 remaining screws had multiple purposes, and given how long I had been eliminating screws, it was looking pretty optimal. But one really stood out. It always bothered me that the screws that secured the Z-axis stopped short of engaging the plastic all the way through to the backside. To fix this, we need some spacer! So I dropped the 6mm screws for 8mm ones plus new 3D printed spacers. The 8mm screw was already in the BOM, so the 6mm could go bite the dust. And thankfully, there was another easy one. Some people disliked how snug the M3 screw fits in the Raspberry Pi mounting holes, so I subbed it for the M2.5 screws already in the BOM.
Elimination.
The M2.5 definitely cramps my style, but the hot end gives me no choice. Its holes are M2.5, so it's here for keeps and it's serving double duty. Actually, quadruple duty, so that helps its case a lot. Rev D dropped us from 12 screw types to just 10. I didn't think I could go any lower, but I already spoiled it for you, so. And finally, that brings us to Rev E. Oh, ow, my foot. This, guys, is a major leap forward for Lemontron. Honestly though, after the announcement video, my life was actually a wreck. But I still obsessed over my Lemontron at every free moment I had for the next year. The first and most important thing was the extruder. What I called the Lemonstruder was a small extruder gear attached directly to the motor shaft. Without mechanical leverage, it ran hot, and there was no room for error. Something I touched on in the previous videos and that almost everyone had trouble with. So 2 mods were published to add gear reduction, although the small space made for some very slight gear reductions. And now I'm releasing an official, extensively tested 4.5:1 full gear reduction solution, right in that sweet spot between torque and speed, using a 16-tooth drive gear, 72-tooth reduction gear with a big extruder gear in the middle, sitting on a post created by swapping out the stock screw with a longer one and spinning on a spacer and a post. And what we have here is the aptly named Endgame Lemonstruder. It now handily maxes out the hot end, and we can absolutely pound filament. This bad boy beats some of the beefiest extruders, and it's shorter than the motor shaft. And that's pretty cool. Just to be clear, the filament drive gear is no longer touching the motor. It doesn't get hot. Even after an 8-hour heat soak, you cannot win in a tug of war with this extruder. It is done. And oh my God, is it good. E is also for tool end. New tool end. If you have a Lemontron or a Positron V3.2, you're familiar with the single duct design. However, there's a dual duct mod by Ollie3D available for the V3.2. Not to be outdone, I aim to bring something like that to the Lemontron, and now we have a 225-degree wraparound duct. This wasn't just slapped together. I went through duct engineering hell. I first designed a dual duct, but that wound up being a dead end once I realized the place where I'd put the second duct was right where the box closes, so that was just sad. Not to be defeated though, I tried a 180-degree curved nozzle next, which although it worked, it was no better than stock. But the valuable lesson was that thin ducting just doesn't work. Suddenly, I realized I could create a full 360-degree nozzle. However, the internal ducting was too complicated still, and the fan choked. It was worse than stock. A beautiful failure. And then clarity. I eliminated the entire quadrant that was the hardest for the air to reach. And when I did, the design started designing itself, which is exactly what you want to see. All the air restrictions let up, unlocking the wraparound duct concept. This new design has characteristics of the first nozzle. Most of the air still shoots out the front, but some of the air is delivered around to the sides. I was able to modulate the air going into each section by calculating the areas of the outlets, which I took to be a fixed size, versus the area of the inlets, which I could vary.
And the result!
High flow, unimpeded by complex ductwork. A sensible, easy to picture flow that leaves little to the imagination, and real world cooling that works seriously well. Here's a Benchy printed on the stock toolhead, and here's one printed on the new one. The only problem is that the plastic's too close to the nozzle. But look, it's there for you if you want to chase the ultimate performance, and of course, it needs to be made at least of ABS, if not something better. This tool end also has a refined probe mount. If you split yours while tightening it down, well, don't fret. This one has surrounding walls to not only prevent cracking, but also reinforce the tabs if they're already cracked. One more tool and update is that I made it slightly taller to better clear the belts. And this isn't an improvement to the design, but after blowing smoke during testing, I realized that some escaped around the inlet. I figured out a simple fix: just seal the inlet with some Subaru or sticky tack for you 90s kids. Other printers could take note. I think it's pretty cool. And one more thing. E is also for motor cooling, because this revision also implements Art Natanon's motor cooling proposal, which butts the fans right up against the motor so that the air can cool the sides of the motors. I'm not sure why I didn't do this, but I had a mental block where I just thought it would make it weaker, but that's not true. Any torque applied to this cutout section here will be taken up by the top plates that bridge over the top. As a bonus, there's even free space to fix some cheap and plentiful VRAM copper heatsinks to the motors for even more surface area. That looks cool. Also, I took the liberty of getting upgraded big fans. Yes, these fans are actually nearly the full height of the chassis. The new cooling solution with the quad fans and 4 times more CFM per fan means we're actually pushing 8 times more air. In fact, when I first printed it and fired it up, I immediately gasped at how much of a difference having these big fans made. In contrast, this previous prototype, which still had the quad fans, but 20mm ones, they still just let the motor soak up all that heat instead of expelling it, like they should be doing. Okay, that was a big win for me. The dopamine is kicking in and my maker spirit is overflowing. Okay, one more thing. I noticed the tensioner takes a large chunk out of the Z-block, the critical part that holds up the Z-axis, and I just felt like there was a cleaner solution than to hollow it out. So I relocated the tensioner down to the bottom, and I retained its adjustability by pivoting it off the motor screw hole and making a little cutout for it to move in. I also noticed that if I stood on the Z-block, it would bend at the weakest point. Now, aside from being very pleased that it held my weight, I saw a simple tweak that could make it a little stronger while removing another bomb item. By shifting the motors out just a few millimeters, I could add some more meat to the Z-block and switch to the preferred size of bearing rather than the small ones, while still fitting everything in. I love this tweak. Time for an embarrassing screw up though. If I'm being honest, it took me months to run a full spool of filament through the Lemontron, but once it starts running out, it starts pulling on the spool, causing the print to fail. Yeah, sorry, that's a design flaw. But it's fixed now. I put a tail on, which docks into the top plate. And sure, it's not the cleanest looking solution, but if the goal was to find a fix that won't malfunction, this is a pretty good one. Also, I added rails to the bed holder, which means you can put it on with one hand. One more thing, I tried printing this bracket in PETG, as I'd recommended as the backup material to PETG-CF, and I found that my Z offset was changing no matter how many calibrations I performed. It took me a while to figure it out, but the problem was twofold. First of all, I realized the lead nut screw could flex up and down. Second, I discovered the edge connector we've all come to love was betraying me. The springs allow a significant 0.4 millimeters of travel in the up-down direction. As for the bracket, I added a reinforcement member along the base to prevent the lead nut seat from bending upwards, and I made the lead nut seat taller overall for further rigidity. As for the edge connector, I redesigned the bracket with a new front receiver that surrounds the PCB tab as it slides into the edge connector, constraining it from all sides. All of this makes me so confident in my Lemontron's ability to print reliably and repeatably. I hope it's clear how every component has been meticulously inspected and improved upon. All of this is to say, Rev-E is peak Lemontron. If you were waiting for a sign to build one, this is it. Have you ever wondered why none of my Lemontrons were yellow like lemons? Well, I was waiting for the right time, and now I can finally show off my actual yellow Lemontron. I can't believe it works as well as it does, and it's a genuinely useful tool that I've manufactured real useful parts with. Here's shower curtain hooks printed on a Rev-E. Here's a fidget cube, a propeller, and a flexi dragon. Here's a literal Lemontron tool head printed on a Lemontron. Here's a microwave replacement button. Here's a PETG-CF hook for my extension cord. Good stuff, guys. Hey guys, I'm almost done editing the video and you're almost done watching it, but guess what showed up in the mail? This box here is from channel sponsor PCB Way, coming through with hopefully some really nice parts. So without any further ado, let's get after it. Oh, these are the gears. Oh, no. How in the world? It's a mirror finish. It is so incredibly smooth. Two 72 tooth reduction gears for the lemon extruder, which of course is usually printed out of ABS plastic, but here they are in metal. That's amazing. Thanks, PCB Way. Let's see what else we have. Now this one should be something quite special indeed, because these are supposed to be crystal clear. I've never seen it myself, but I've seen it on Matt Denton's YouTube channel. We're looking at a left and right top plate here. The left top plate was $46 and the right top plate was $35. We're gonna see if it was worth it. Let's check it out. What the oh my God. Oh, holy crap, it's crystal clear. That is a crystal clear right top plate. Wow, that's insane. All right, let's grab the left one. That's incredible. That came out just like I imagined it. Oh, PCB Way coming through. Oh my God, look at these guys. Look at this. Just look at these things. This is a 3D printed part. Now I hear that these parts are printed like at a slant. They won't print them like this. And then they go and polish them and then they spray varnish it. Anyways, I am so excited. I can't wait to get these fitted to the Lemontron. So let's go see what these things look like. Oh, but we can't forget about PCB Way's PCBs. Here's our Lemontron breakout PCBs. This one's version 1.3. It just fixes a silkscreen issue, so no big deal, but definitely good to have. You get 10 of these for $5. PCB Way is every maker's best friend because it's like having a world-class machine shop on standby. You got every 3D printing technology at your disposal, and yes, you can print titanium. These parts for sure show off some of PCB Way's advantages, but in the grand scheme of things, this is just a tiny peek into what they can do. The gears underwent a nickel plating process, one of many industrial finishes PCB Way offers, and they make this too easy. For you, all this is a simple drop down. For PCB Way, this kicks off multiple complex assembly lines and engages multiple specialists working together because every part has to come out perfect. Complexity hidden from you, all you do is select from a friggin' drop down. If I had more time, I'd get some more parts made, like maybe 1.5 GT drive gears. How about a Lemontron Ultra size that has a 250 by 250 build plate? The PCB Way partnership is the best thing to come out of this project, so big thanks to PCB Way. Now at this point I realized that in my excitement I forgot to install the Bowden tube, so I took the left top plate back off. Now I was concerned about the Bowden tube here and it turned out to be a valid concern because I had to find some way to bore out the internal channels. But it gave me a chance to use these springs, which I just think is kind of funny because I've been holding on to these springs since I was like 10 years old. So these springs predate the iPhone and broadband internet, and yeah, it just brings me back to the time when I was a kid making Nerf blasters and Beyblades. And finally, I have a use for this spring, so 20 years later. Now the tail fits perfectly and we can put it back together again. And I can insert the Bowden tube into the tool head and wrap it up. There are still a couple of things I want to chase down. One is this wild idea of going full direct drive. Honestly, it feels borderline impossible with the current form factor, so don't hold your breath. But I can't help wonder if there's a way. The other issue, and it's a stubborn one, is VFAs. They're still there. Like with every other printer, I suspect it's belt related, and maybe I can solve it, but this one remains a mystery. I have a long-winded test I can do, which is to switch to a 6mm belt, but it will require some pretty involved refactoring. When will these updates come? I don't know. Part of me thinks I've overextended myself with such a passion project. I've squandered more lucrative opportunities in favor of pumping away at the Lemontron. The other part of me just wants to keep honing it to perfection. I'm at a crossroads now, especially since, and this is on a more personal note, I've been between jobs. I could really use your support right now, so subscribe and maybe become a full-blown patron that could afford me more zesty runway. I am just a nerd with a dream, like all of you.